My name is Francisco Tolmasky. I am a co-founder of a company called 280 North. I founded that with two of my best friends from college who are also here at JSConf. So if you have any questions, you can hit any one of us. We're probably going to be wearing 280 North shirts. So what I'm here to talk about today is a JavaScript framework we created called Cappuccino. Just out of curiosity, how many of you have heard of it, just so I know whether I should focus on? Okay, good. So something we like to say a lot, and we always try to start our presentations this way, is by describing exactly what it's for and what it's not for. Cappuccino is for what we call desktop class applications. And by that we mean kind of the applications that you used to expect running on the desktop and that a lot of people thought would never make it to the web, but are more and more going there today. So, we like to think of the web as this giant spectrum, right? And when the web first started, it had this kind of web page in mind. The traditional RESTful web, something like New York Times, just a bunch of pages connected by hyperlinks. And then over time, they got a little more dynamic, things like Amazon.com. Now, Amazon.com still fits this original vision of the web really well, but you can't deny that it's not an application, right? You can put your credit card number in there, thus it's an application. So it does things as well as present things. Then you have things like Facebook, which are like exactly in the middle. They are very RESTful, right? Every single user has their own page, and that page doesn't change and everything. But on the other hand, every single page can have like 30 different apps running on it. So this is like something that's very unique to the web. And then on the far right of the spectrum, you have things like Google Maps. And Google Maps is actually a really great example of this kind of app because Microsoft actually originally argued against the web platform by saying they'll never be able to do something like Maps. Well, they were wrong, and this kind of kicked off the revolution of doing incredibly dynamic things you'd only expect on the desktop before on the web. So we really wanted to build this kind of application on the web like 3 years ago or something. Something like that. And the problem was that the tools for doing it, even though the web was capable of doing it, the tools weren't really there to do it. And it's not because the tools were bad, it's that the tools focused on different things, right? The tools were really, optimized for building things like New York Times or Amazon.com, that sort of thing. Just when Google Maps first came out, no one had already made a framework for it for anything. So we wanted to make a framework that really targeted this right hand of the spectrum, what we call desktop class applications. And you can really tell that this is necessary because if you go hit view source on any one of these applications, one of the great things of the web, you'll see that all of them have basically done each other's job over and over again, right? Meebo is a great example. Meebo is, I use that instead of iChat a lot, and it's a really great web app. Yet they have to put so many resources into drawing windows and drawing buttons and basically putting together a windowing system. And it really sucks that for a chat application, their strategic advantage to be, we hired 20 people to write a windowing system. That's not what the web should be, right? That should be a solved problem, and you should be able to focus on what makes your application unique. So I want to give you an example of the first app we wrote using this framework. It's called 280 Slides. And I will go ahead and do that right now. There we go. So this is 280 Slides. It's kind of like Keynote or PowerPoint on the web, and it's running in Safari. And you can, of course, do what you'd expect to be able to do, kind of make a title and set the font or whatever. But again, we really wanted that desktop feel. So we really tried to get media right. So, we've got shapes, and you can do whatever you want with them, and this will work in, IE or Firefox or whatever. And we don't stop there. We let you do any arbitrary media. So you can do a search for an image on Google Images. You can drag that in. This is just going to work. It's going to be fast. And of course, just like on the desktop, all your key bindings should work, right? So copy-paste should work, and that shouldn't be just bound to text or images. I should be able to do it, on slide level. If I move things around, undo should just work. So all this, and you can undo all the way to the beginning of your document, etc. And of course, you can do this with movies as well. So I'll just do a quick search here. So and you can quick look this just like on Mac OS X, and here we go. It's loading up YouTube. There we go. So you can kind of preview your movie before you see it. You guys believe me that this is a real movie, not an animated GIF, right? I can close this. Good. So then you can drag it in if you want. So that's kind of the idea. We wanted something that really felt like a real application. And I want to show you one more application. This one was just released a couple days ago, not by us. It's called Mockingbird. It's kind of like Balsamic. Have you guys played around with Balsamic at all? But it's written completely with web standards technologies on top of Cappuccino. And it's just kind of the same thing. You can lay out a UI. And if you want to link to another page, you can just, here you have your different pages. You can just kind of drag in the other page, and now it's linked to it. So there you go. So you guys should just play around with this. Go mockingbird.com. So there you go. So the way we decided to build this is by taking an existing technology that we thought already worked really well. And we're all former Mac guys, and we used to write Mac software. And Cocoa is the way you write applications on the Mac, and we really like it. It's a really great framework for doing very visual UI-driven things. And what really sealed the deal for us was the fact that Cocoa has been around for like 20 years. Like, Next Step was running this, then Mac started running it. And a few years ago, they took this existing framework and shoved it into a completely different environment, the iPhone. And if you look at iPhone apps, they look pretty darn good. So that to us kind of proved this framework. The fact that you could take something, a 20-year-old idea, put it on a completely different platform, and revolutionize the industry. Well, maybe they're doing it because of the framework, not in spite of it, right? So we said, well, if you can make great apps on the Mac and the iPhone, why not the web? So basically, what Cappuccino is a port of the Cocoa frameworks from the Mac and from the iPhone onto the web. So to do that, we actually created a new language on top of JavaScript. It's called ObjectiveJ. It just adds a few new features to JavaScript. So if you've ever wanted to be able to do classical inheritance or be able to, import scripts, that sort of thing, ObjectiveJ handles it. The nice thing about ObjectiveJ is that it's a strict superset of JavaScript, and that's just a fancy way of saying any existing JavaScript will work with ObjectiveJ. So you can take any existing JavaScript framework, mix it together with ObjectiveJ, it's just going to work. You don't need to compile it or anything. It'll just work in the browser. So what I really want to focus on today is our new version that we're going to be launching soon. It's called 0.8. We're in beta right now, so we're calling it 0.79. And we focused on a lot of different things for this version, but I'm going to only hit about 3 today. And the first big one I want to hit is CommonJS, and I'm really glad that Chris got to kind of give you guys an introduction to this before me, so I don't have to focus too much. But CommonJS is really, really important. It's really embarrassing as a community that anytime we want to do something on the terminal, we have to use a different language. And someone asked earlier, what's a great use case for CommonJS? Well, 280 slides runs JavaScript in the server, and it sucked having to do it without something like CommonJS. We had to do it on top of Rhino, which is, one of the few engines competing for the medal of slowest implementation, I guess. I don't know. It's terrible. On top of that, anytime you want to do anything, you have to drop down to Java. I didn't start programming JavaScript to program Java, so equally terrible. And so basically, when it comes to the terminal, you can't really do a lot with JavaScript. You can add numbers, but the second you want to print that result, no standard way, right? The second you want to read a file, you can't do that. So CommonJS is incredibly important to the JavaScript community, and we've invested heavily in it in the next version of Cappuccino. So the way we've invested in it is we've built our entire build process on top of CommonJS. We've ported all our tools to CommonJS, and we're also going to handle distribution through CommonJS. So let me kind of explain a little deeper. When we first did Cappuccino, we didn't need a build system because it's JavaScript, but as it turns out, that's kind of a little lie we tell people. Oh, it's interpreted, you don't need a build. Well, you do. You need to minify it. You need to concat, all this stuff. So Cappuccino is a pretty big framework, and it requires doing all this. And originally, we just wanted something that A, was not make, and B, could be run cross-platform. And so we settled on Ant. It's XML, it must be good. No, it's not. One of the nice things about Ant was that you can kind of run JavaScript in it. It has a script tag, but you can't really. And then the second you want to do something like if, well, you can't, no, sorry. No conditionals, guys. You need an external library to do a conditional on Ant. So that was pretty terrible. So At one point, we had half in Ant and like half in this, half JavaScript stuff and script. It was a complete mess. Like most our bug reports were like, I don't know how to build this. So then we moved to Rake, and I have to say that I like Rake a lot. It's the first build system that didn't make me want to gouge my eyes out. It's a really fantastic tool. I actually learned Ruby through Rake, so that should tell you how great it is. Like I didn't even know the language, and I just kind of picked it up. And we ported everything in Cappuccino from Ant to Rake. Now that being said, it still kind of sucks that it's not JavaScript for a number of reasons. For starters, it's kind of a barrier to entry if someone wants to fix a build bug, right? They come in, they're expecting just JavaScript, and then something doesn't work in the build scripts, and they don't really know what to do. And sure, learning Ruby is easy, but the answer shouldn't be, oh, just learn this new language. Then you can continue programming in JavaScript. No, that's not the right thing. Additionally, it's nice to be able to use your own idioms when you're doing other stuff. And the last kind of real deal breaker for us was that we had written all these great tools, for Cappuccino and JavaScript, and we couldn't even use them in our build system. So we ended up at this point where we had a parallel set of tools. So we would write something that did something fancy in ObjectiveJ, and then we'd have to write it in Ruby too, just so we could use it on, on the terminal as well as on the client-side browser. So it became just a management mess. So what we did was basically take Rake and do a direct port to JavaScript. It's called Jake, and it runs on top of CommonJS. It's really nice because it really is a direct port. So we built Atlas on Rake, and we were able to translate it to Jake in I think half an hour to an hour. So I'm just going to quickly show you what that's like. So has anyone here used Rake? Do you guys use Rake for your own projects? Okay. So this is kind of how you do things in Rake. You have this build task, and then you can do stuff. So this with Jake just looks like this. So it's a little bit longer because we got that function keyword, but basically, there's a syntax error there, sorry. Get rid of that parentheses. So basically, if you want to build something called hello, it'll do whatever's in that function. This is how you set up dependencies in Rake. You say, well, if you want to build hello, you have to build dependency 1 and dependency 2 first. And this is how you do it in Jake, so just pass in an array. As you can see, we obviously have to use strings instead of symbols or whatever. The other nice thing about Rake is that you can just kind of append dependencies to an existing task, and that still works the same with Jake. And it has this really nifty file task, which basically says, if the file on the right is dirty, rebuild the file on the left. And that's exactly the same. So again, if you already have Rake build scripts, it'll be really easy to convert them to Jake, and then you can use all your tools and stuff. So we're really happy with that. So we really love CommonJS, and everyone knows that for a healthy relationship, it's good for the other way to be true too. So what's really cool about CommonJS is that it's fluent in ObjectiveJ as well as JavaScript. So this is the way we're going to ship Cappuccino, the next version. So instead of this, go to this website and click something, there's the Tusk, which is kind of like gem. It's kind of like Ruby gems. And you'll just be able to type Tusk install Cappuccino, and you'll have Cappuccino installed on your system. And that solves a really big problem for us, which is, distribution. So this is one example of one of the many Cappuccino frameworks out there. It's called MapKit. It allows you to put Google Maps into your websites and stuff. And this sucks today. It sucks for JavaScript programmers. You have to go search a mailing list. Oh, here's the GitHub URL. Which branch do I download? It's terrible. But starting with 08, you'll just be able to do this, and you will be able to use it in all your apps. So I'm really excited about that. And this is just kind of the way you define your little CommonJS module. And the only thing I wanted to point out is that there's these ObjectiveJ frameworks and ObjectiveJ debug frameworks fields, which let you say, this is my ObjectiveJ stuff. So you can ship ObjectiveJ and JavaScript. So I'm really looking forward to being able to have, like a nice package website where people can, easily install stuff. The other big thing we wanted to focus on was performance, and the only aspect of that I'm going to talk about today is spriting. So spriting is not just for images, right? It's kind of this abstract concept, and the one form of spriting that I think all JavaScript frameworks get right is spriting of actual scripts, right? You go in and you have a million JS files, and if you want something performant, you kind of concatenate them all together, and that's, poor man spriting for that. Um, so the one that's more interesting, though, and fewer frameworks get right, is images. So this is exactly the same idea, right? You have a bunch of images, and if you leave them all separate, when you load them up, you get lots of latency because every single image is a different request. And more importantly, it looks really bad if you don't sprite them, right? Because your website's loaded and then stuff kind of just starts coming in. So this is something that admittedly Cappuccino 0.7 did really poorly. And by really poorly, I mean not at all. So one of the things we wanted to do was get this right. So the benefits of spriting, again, are obvious, right? You get less image overhead. If you put a bunch of images together, all that redundant stuff kind of goes away, right? All the headers of an image. Less latency, right? You push one thing instead of many. And again, there's this perceived speed issue, right? Your website feels faster because everything snaps in. But there are a bunch of problems with spriting, too. And I think spriting right now is still kind of primitive in that it's not so much an optimization, it's kind of a manual task that you have to do, right? When we first started spriting script files together, when we first started doing minimization of JavaScript, it was kind of broken, right? Like the very first minimizers would sometimes mess up on your code, and then you had this thing that worked when you just shipped the JavaScript, but then you minimized it, and it didn't work, and you weren't quite sure why, and then you went back, and it's, oh, it doesn't understand global variables, so I have to do all this stuff. And what I'm trying to say by that is that with minimization, originally, we had to do all this work to work around the minimizer, right? Because it didn't really understand JavaScript that well. And that's, I think, the stage we're at right now with image spriting. Because the spriter doesn't know if your thing's going to repeat horizontally or vertically, or going to need to be stretched, or if it's going to be drawn to a canvas. So it's not as easy as just saying, take my images and make them optimized. You actually have to physically go in there and say, okay, this one's for horizontal, this one's for vertical, blah, blah, blah. Then someone goes in, changes the code, and now it's broken. So that sucks. We wanted to fix that. So the solution we came up with was, the result of all that is that this dream of, you take all your images and you get kind of one shippable image isn't really true, right? You end up with, you take a bunch of images and you ship the horizontal, the vertical, the stretchables, and whatever. So it's certainly better than shipping a bunch of individual images, but it's not that dream of shipping one thing that just works. And on top of that, you also have to ship your code separately. So maybe 5 downloads instead of 25. It would still be nice if it could be 1. So this kind of solves that problem. The data URL allows you to put image data right into text. What's really nice about this is that you can make it 100% automated, right? You can take all your images and shove them into a text file as data URLs. Not a problem. It doesn't matter if they're vertical, if they're horizontal, if you're going to draw them to canvas. They're just basically binary data in your text file, so it just works. The other really nice thing about this is that you always get one file, no matter what, for that same reason. You can always shove everything in one file. What are the problems with data URLs? Well, one of the problems is that the files get slightly bigger. Base 64 is slightly bigger than the actual binary representation. It's not so bad when you turn gzipping on, since it handles a lot of the common stuff anyways. But I think the main problem that most people have on their minds as I say this right now is, well, it doesn't work on IE. Well, it does work in IE, as it turns out, and it has since IE 6, and it's called mHTML. And this is like their format for basically shipping any arbitrary resource. So what we've done is actually built this into Cappuccino. If you have images, it'll automatically mHTML them or base64 URLify them. And so your entire app, the whole thing, text, images, everything, gets shipped in one download. And we've been trying this out, and it's really amazing. It feels great. This is all of Cappuccino proper. This is Foundation, AppKit, the default theme. It's just 250K gzipped. And what's really nice is it's everything, right? It's images, everything. You're done with one download. So the other nice thing about this is that we built this into the build tool. So if you have a Cappuccino application, it will automatically do this for you. So I think this is the way to do spriting, because the other way just doesn't scale, in my opinion. The way of, hey, this guy changes code and all of a sudden the images show up incorrectly. The bigger and bigger your apps get, you're going to want something that just works. And I'm really excited about shipping that feature. The other thing we've been focusing a lot on is one of our users' favorite tools, which is nib to sib. Are you guys familiar with Apple's interface builder on the Mac? No? Okay, I will show it to you right now. So as I said, we kind of formed Cappuccino because we really like the way you make applications on the Mac. And one of the big differences between the way you make applications on the Mac and the way you make applications elsewhere is this tool called Interface Builder. So the way you actually start an application on the Mac is you start up Interface Builder and you actually edit your interface. And this will take a second here. So this is kind of just the Mac app right now. If I hit run, there's the Mac app. It just says Hello World on it. And what you can actually do with Cappuccino is take this interface and convert it so that it works on the web. So if I double click this is actually like kind of the default way that you make applications on with Cappuccino. So as you can see, there's a tiny bit of difference, right? This is kind of full screened instead of a little individual window. The reason for that is here we just tell the window to get full screen, but if I turn that off, it'll look exactly like the one I just showed you, right? So let me show you how you actually do stuff. I'm going to build kind of a little contrived example. You would never do this in real life. I'm going to build a browser within the browser. But it'll give you an idea of all the widgets and stuff. So the first thing we want is our little browser window. So I'm just going to drag out a window here. And this is my new window. I'm going to make it a little bigger. And now we want a URL field to actually be able to type the URL, right? So I'm going to grab this URL, this text field, and drag it out, make it a little bigger. Now I'm going to grab a button. This is our back button. Type back. And I'm going to grab a web view. So this is where Interface Builder really shines, because this is kind of, with other UI builders, this is where you stop. Like, okay, now I got to assign an ID, and then I'll go get it. No. That's not what you do in Interface Builder. Interface Builder allows you to take the next step of actually assigning behaviors to these elements. So this is my browser. So what I'm going to do is Control-click, and I'm going to connect this and say, you know what? Just take the URL from this text field. And I'm going to connect this button. And I'm going to say, well, go back. So the last thing we want to do is actually be able to show this window. So I'm going to open up my main menu. And we'll go to the window here, and we'll just type browser. And I'm going to click here, and I'm going to hit Command-B. So that's another way to open it up. And now again, I want to show this window, so all I do is Control-click from the menu item to the window and call order front. And the last thing I'm going to do is just say that this window should not be visible when we originally launched the program. So I'll save this, and I will run nib to sib once again. And now when I refresh, move this out of the way. We've got this browser. Here it is. I can type in a URL. And it's a little slow, but it's loading. It's loading. No internet? All right, guys, stop torrenting for a little bit so I can do my demo here. Oh, no, but I'm Etherneted. This should be, rock solid. All right, well, sorry, guys. This would show apple.com. But the other nice thing is I can close this window, and again, I can hit Command-B, and it'll just open up. I don't need to worry about the key presses or key commands or whatever. It's just going to work if you have an internet connection. So I wanted to show you a real-life example, right? This is just a demo. But Sofa just launched their own Cappuccino application for their new app, which is building stores online. And this is it. So you kind of, set up like how people can buy stuff or whatever. It's just like a management tool for setting up a website. And this was built entirely using nib to sib. So every single piece of UI you see was actually built on a Mac, tested first on a Mac, and then converted to the web. So that's pretty exciting, and obviously written with JavaScript and ObjectiveJ. And I'll show you that in more detail in a second as well. So that's nib to sib. It allows you to use Interface Builder. This is all open source, of course, so you can download it and just use it. It makes making these kind of apps a lot easier. So now I want to talk about the product that we're going to be releasing pretty soon, which is called 280 Atlas. Get back to my presentation just to show that slide. So basically, nib to sib is pretty cool, and it got us, part of the way there. But it's not the full answer, right? It's designed for desktop apps. The widgets don't look exactly the same as when we convert them for the web. It's not built to talk to web services, that sort of thing. So what we've done is actually build our own version of this called Atlas. So I'm going to go ahead and launch that, and I'll show it to you right now. So I'm going to make a new project. So this is the kind of project manager. Here's our code. You can, type your JavaScript or ObjectiveJ or whatever. But again, the kind of what makes this different is the interface editing capabilities. So I come here, and this should look familiar. It's kind of like Interface Builder. If I double-click this, let me make the window a little bigger. This is kind of like our browser window, right? It looks like a little browser window. So I can do just a quick example here. I'll drag this in, and I'll drag in a text field. And these guides are really smart. They're not just, aligned to something else. They actually tell you, this should be 10 pixels away from this guy or whatever. So we have the same connection technology as Interface Builder, so I can actually connect these two and just say, take the float value from this. And if I save it and hit run, actually, let me do one more thing. That's so it stays centered. So now if I hit run, it'll launch up Safari. And here we go. This is our slider in our text field. And as you see, if I kind of move it across, it's just going to stay updated thanks to that connection. So all these built-in connections are nice, but obviously they can only do what the original widget designer intended them to do. So I want to show you how to build new kinds of connections. So I'm going to do another kind of simple example. The first thing, I'm going to make this just an ordinary window like we did in Interface Builder. So I'm just going to say, do not fill the browser window. So now it becomes a normal window. And I'm going to drag out just an ordinary view that does nothing. Drag out a button. We'll label this one blue. I'll drag out another button. We'll label this one red. Now again, I want to write code that interacts with these objects, and that's going to be hard to do because they exist in, layout land and not code land. So what I'm going to do here is just come to my code and create an outlet. So I'm going to say @outlet, cpView, myView. Save that, and if I come back now, here's that object that I just edited. It understands that this can be a view, so I'm going to connect that. Now I've connected that view. So anytime I write in my code, my view, it's going to be talking about that object. But now I want to be able to do something from those buttons. So if I show you, if I try to make a connection from my button, it doesn't work. So what I'm going to do is create an action. So I'm going to come here and type @action, make view red. And I'll do another one for the blue. Save that. And now if I come back to my interface, I can connect, and I can choose make view red, connect here, select make view blue. And if I save and run, here's the window. If I hit red, it becomes red. If I hit blue, it becomes blue. There you go. So one of the things that Cappuccino gets really right is what we like to call document-based applications. So things like Mockingbird that I showed you, where you make a document, or 280 slides and you have to save and all that sort of thing. So what I'd like to, oops, actually let me quit it. So what I'd like to do now is show you an example of making a document-based application. So I'm going to come here and I'm going to say new, and I'm going to choose document-based app, and we're going to make a text editor. And all of you are familiar with Bespin, yes? Our friend Dion over here created. So if I go to my resources, I have the main interface, just like before. It has my menu and stuff. But I also have another interface file specifically for my documents. So if I come here, right now it just has nothing. So if I click run, it's just going to load kind of an empty document-based application, right? And I can make many of them, but obviously they're pretty useless. There you go. So Atlas is really extensible with plugins, so what we've decided to do is just build in Bespin. So I can drag Bespin out, just drag and drop it in. I'm just going to make it the entire size of the window. And I will set the resizing flags here to kind of stretch with the window. So one of the nice things is you don't have to keep switching between browser and Atlas all the time. We have this test button where you can just say test in place. So it's all kind of embiggen it in place. So there you go, there's Bespin. So we can make sure that it works before we actually commit to trying the whole app, and it seems to be okay. So now let's actually go ahead and try it in the browser. So there's Bespin, and I can make, lots of them, and I can come in here and I can type. I make syntax errors, there we go. And these are also very smart. They all have their own individual undo stacks. As you can see, I'm undoing here, and then I can come here and undo there, and everything's just going to work. So the other big problem we wanted to solve with Atlas was, you put in all this work and you make this really great web app, but at least for the time being, there's a really big problem with, well, what happens when I'm offline, right? Or what happens when, I want to sell to someone who doesn't really trust hitting my servers for their information. So again, Cappuccino wasn't necessarily about the web. It was about applications that happened to run on the web. So what we've done is you can come up here to this pop-up button, and right now it's set up to run on the browser. But I can just select native desktop, and instead of hitting run, I'm going to hit build. This will take a second. And as you can see, this is the same exact JavaScript application. This is all running JavaScript, running natively on my Mac, and I can make new documents and whatever. So this is now a text editor that runs both on my desktop and on the web. And if you didn't notice before, this is actually how we built Atlas. When I was editing code, this is actually just a Bespin view. So we built Atlas in Atlas. Every single line of code that I showed you today is 100% JavaScript and ObjectiveJ. And to give you one additional example of that, I'm going to go ahead and open up 280 slides, which we wrote a while ago, before we even started all this stuff. So this is a 280 slides project. And if you recall, here it was running in the browser. So now this is the exact same code. I'm just going to select native desktop. I'm going to hit build. This one's going to take a little longer because there's actual stuff in there. It's not a demo. There we go. So it launches up. I can say create new application. I can select this. And here's 280 slides running as a desktop. Oops. Sorry about that. So here's 280 slides running as a desktop application. So if you're not online, you can still create and edit your presentations, do whatever. Here's that little media panel. It becomes a real deal window. So everything just works the way you'd expect it to work offline and online. So that's Atlas. My computer's crashing here. There we go. Yep, okay. There we go. So that's Atlas. We're going to be releasing the beta as a paid beta for $20 November 15th. That's a week from now. So you won't see me online for that whole week as I'm fixing bugs. It's really cool, I think. We're going to be seeding stuff out about once a week. You're going to be able to test it out, kind of help us finish it along. And then when we release the final, obviously the $20 will be removed from that price. So everything I showed you except for Atlas is completely open source. You can check it out on 280north/Cappuccino on GitHub. If you go to just 280 North, you'll see all our projects, and this will include like CommonJS. We have a pretty far along implementation of that called Narwhal, which Tom will be talking about tomorrow, Jake, all these tools that I showed you. And yeah, and you can always hit cappuccino.org. It is the first hit for Cappuccino on Google if you spell it correctly. And here are some more links. Thanks a lot, guys.
Thank you, Francisco. Do you guys have any questions for Francisco while he's up here?
No. Oh yes, the question was when in Atlas we turn web apps into desktop apps so they only run on OS 10, and the answer is no. When we ship Atlas, it will work both on OS 10 and Windows. I mean, it's just web stuff, guys. That's the whole point of relying on standards. The Bespin editor plugin will only run on the browsers that Bespin supports. All of Cappuccino works, IE, Firefox, Safari, everything. But if external parties build plugins that only work on one, then they'll only work there. Yeah, so when you run, so the question was, are there hooks for OS-specific things? So the way, again, I didn't have a lot of time to get into a lot of detail of how this desktop stuff kind of magically works, and you can talk to the file system and stuff. But basically, when you ship a web app, you have the client-side component and the server component, right? And you do front-end stuff on the client side, and then when you want to save a file or whatever, it gets pushed to the server. So we have that exact same architecture on the desktop apps. So we actually ship your server code with your client-side code in these desktop apps, and the server code can do whatever it wants. It can write files, it can read files, it can start other processes, whatever. So if you want to, from your client-side JavaScript, do something, platform-specific, all you have to do is create a RESTful request to your own little private server, which can then do whatever it wants on any operating system, right? Does that make sense? Okay.
How would you compare Cappuccino to Sprout?
Way better? No. How would we compare Sprout Core to Cappuccino? I mean, they're really two different approaches to a problem. Our approach was Cocoa is a really great framework. We want to get that up and running as fast as possible on the web. It's kind of similar to what we did with Jake, right? We're not out here to reinvent build tools. Like, that's not an interesting problem. Someone's already gotten it right. People a lot older than me and a lot wiser than me have figured out the APIs and gotten it all right. There's not that much difference between the desktop and the web. Let's just get it up and running. And that's the reason that we're able to do things like nib to sib with Interface Builder, the reason we're able to do Atlas, all this stuff. We have a running head start because we're cheating. We're using something that's already proven to work really well. Does that answer your question?
So why Apple's using Sprout or Cappuccino?
Well, Apple's using a lot of frameworks. I mean, they're using jQuery on the main Apple site, and they're using Dojo on other parts of the site. And for some reason, the part of the site that they hired a bunch of contractors who wrote Sprout Core is using Sprout Core. So there you go. Cool. Thank you.